Hello my dear children of class 11 science. Today we do continue with the new unit which we had already started in the last class, that is behavior of perfect gas and kinetic theory of gases. Okay, so this is unit number 9 and only one chapter. Okay, unit number 9 and only one chapter. Now in this particular class, okay, we start with the relation of, especially the SI unit of what? R. Actually R is called universal gas constant. And children, remember that in the last YouTube video we have done up to the equation called perfect gas equation, also called ideal gas equation. And you know what is perfect gas equation? PB equals to nRT. So this is the relation we have done it. PB equals to nRT. P means pressure, B means volume, N is the number of mole of the gas, R is the universal gas constant, and T is the temperature, the absolute temperature. Okay. Now this is called perfect gas or ideal gas equation for N mole of the gas. This is for N, okay, mole, okay, of a gas. N mole of a what? Gas. Now from this relation, okay, we now write the SI unit of what? R. Okay, R is a constant, but we write the unit of what? R. So what I do, I'll make R as the subject. If I make R as the subject, from here then I write down R equals to PB by NT. Just see, if I make R as the subject, then this N and T will go in the denominator of this left hand side PB. So which means R is nothing but PB by what? NT. Okay. Now I write the unit of R. So unit of R means, the unit of R means nothing but the unit of what? Pressure. P means what? Pressure, into the unit of what? Volume. Unit of B means volume divided by N. Okay, N means the mole. Okay, N means nothing but the mole. Okay, into the unit of absolute temperature. The unit of absolute temperature. Absolute what? Temperature. Okay. Now we know what is the unit of pressure, and we write this unit as the SI unit. And pressure SI unit is Pascal, but this Pascal of pressure, the SI unit, is also equals to Newton per meter square. Newton per meter square. I am writing this way. Your SI unit of pressure is Newton per meter square. Okay, into volume. And you know what is the SI unit of volume? Meter cube. SI unit of volume is meter cube. SI unit of pressure is Newton per meter square. N means Newton. Okay, whole divided by this N means nothing but the mole. So we write mole only. We write what? Mole. Into what? SI unit of what? Absolute temperature. That means the absolute unit of temperature is nothing but Kelvin. And we write by the symbol what? K. We simply write by the symbol K. Now let's further simplify. So this will be Newton into meter minus 2 and meter cube, means we can write as meter 1, because 3 minus 2 is 1. See, 3 minus 2 is 1. So Newton meter by mole into what? K means what? Kelvin. K means what? Kelvin. Now children, you know that Newton meter means force. The unit of force and unit of displacement is actually equals to work, and the unit of work, as unit of work, is what? Joule. So Newton meter is equivalent to what? Joule. So I write down now this as Joule. So Newton meter is nothing but Joule by mole into K means what? Kelvin. K means what? Kelvin. Which means I write the same now as by the unit symbol Joule per mole. So this mole has a unit MOL only, so it will be given by per mole, and Kelvin I take in the numerator per Kelvin. So it means SI unit of universal gas constant is Joule per mole per Kelvin. So children, finally we wrote the expression. I mean the unit of what? SI unit of what? Universal gas constant, which is nothing but Joule per mole per Kelvin. But one thing I want to tell you, that when there is a change in temperature, when the temperature rises or fall, okay, there is a case that the difference in what? Just let me write it down. The difference of 1 Kelvin rise in temperature, 1 Kelvin rise, or what? Fall in temperature. Fall in what? Temperature. Fall in temperature is always equals to 1 degree Celsius rise or fall in temperature. fall in what? Temperature. So if the temperature rises, say by 1 Kelvin, that is also equals to temperature rises by 1 degree Celsius. That means the change in temperature, let me just tell you, the change in temperature, if it is 1 Kelvin, that is also equals to what? 1 degree Celsius. That means equal rise in degree, equal change in temperature in Kelvin to equal change in temperature in 1 degree Celsius. Okay, which means if the temperature changes, okay, by the same amount, okay, then the SI unit, I mean the unit of what? R, I don't, the unit of what? Unit of R can also be written as joule per mole per degree Celsius, So we can write this way also. So see, joule per mole per degree Celsius can also be written as the unit of what? R. But this is not the SI unit exactly, because degree Celsius is not the SI unit of temperature. So if it asks that to write the SI unit of R, then we need to write joule per mole per Kelvin. Whereas the unit of R can even written by joule per mole per degree Celsius. So this is the what? SI unit of what? R. Now we have a next one, that is the value. The value of what? R. So R as a universal gas constant, it has a particular value. It has a fixed value. And this value is same for all the what? Gases of any nature, okay, and at under all the condition. And this value can also be calculated. Now in order to calculate the numerical value of R, okay, which is a constant value and universal value of R, okay, let me just go back again to the perfect gas equation, and this is nothing but PV equals to nRT. So again I am writing the same equation, PV equals to nRT, and this is for n mole of the gas. This is for what? N mole of the gas. Now to calculate the value of R, so let me just take a 1 mole of the gas. This is now I will do for what? For 1 mole of the gas. 1 mole of, and what gas? We are basically dealing with what gas? Ideal gas. Okay. So 1 mole of an ideal gas, okay, according to Avogadro hypothesis. As we know, you have learned in chemistry also, according to what? Avogadro's hypothesis. Avogadro's hypothesis. Now hypothesis means is such a statement which may be true or may not be what? True. Okay. Now is under a consideration. So according to Avogadro's hypothesis, at normal temperature and pressure, normal temperature and pressure, and you know now what is normal temperature pressure means? NTP. So let me just write in form NTP. You have learned in chemistry, at normal temperature pressure, normal T means temperature, P means what? Pressure. And your normal temperature is, just write it down, your normal temperature is always how much? Okay, your normal temperature is always how much? How much degree Celsius? 0 degree Celsius. And you know 0 degree Celsius is also how much? 273 Kelvin. Because when you convert 0 degree Celsius to Kelvin, degree Celsius to Kelvin, we need to add 273. So what is the normal temperature? 0 degree Celsius or 273 Kelvin. Okay. And your normal pressure is, and your normal what? Pressure. And your normal pressure is almost 1 atmosphere. Normal pressure means always what? 1 atmosphere. Now 1 atmosphere is also equivalent to 1.013 into 10 to the power 5 Newton per meter square. So children, this part you have even learned in class 9 in the chapter called pressure exerted by the fluid, okay, and normal pressure, atmospheric pressure, and that pressure can be 1 atmospheric pressure as a normal pressure, which is also equivalent to 1.013 into 10 to the power 5 Newton per meter square. So I am writing this value of T and P in what? Which unit? SI unit, because K is the Kelvin and Kelvin is the SI unit of temperature, and Newton per meter square is also the SI unit of what? Pressure, which means your temperature is what? 273 Kelvin. Your pressure is, normal pressure is how much? 1.013 into 10 to the power what? 5 Newton per meter square. Okay. So at this temperature and pressure, according to Avogadro hypothesis, it says that the volume, so this is very important, the volume of 1 mole. The volume of what? 1 mole of a gas. Of a gas. Means any gas is always 22.4 liters. The volume of every 1 mole of what gas? Ideal gas is equals to how much? 22.4 liters. Means every ideal gas acquire a volume of 22.4 liters for how many mole of gas? 1 mole of gas. Now this is a liter, the unit of volume, but liter is not as a unit of what? Volume. So we can even write this as what? In what? Meter cube. So it can be equals to 22.4 into 10 to the power minus 3 meter cube, because meter cube is the SI unit of what? Volume. But children, remember this part, 1 liter is equals to 10 to the power minus 3 meter cube. So to convert from liter to meter cube, we multiply by 10 to the power minus what? 3. So from here I can say that the volume of 1 mole of every ideal gas is almost 22.4 liter. That is 22.4 into 10 to the minus 3 meter cube. So with this value of volume, pressure, temperature, and for 1 mole of the gas, we can calculate the value of what? R. Now I write down. Therefore, R equals to PB by what? NT. So children, look at this. PB equals nRT. So if I make R as the subject, then PB equals PB by what? NT. Now for 1 mole of gas. So 1 mole of gas means basically for 1 mole of gas means N value is what? 1. So let me write at the side. Okay, the value of N, this is N equals to 1, small n equals to 1. Okay, so for 1 mole of gas, the pressure of the gas is a normal pressure, at normal pressure and normal temperature. The volume of every 1 mole of the gas is equals to how much? 22.4 liters, or 22.4 into 10 to the minus 3 meter cube. So let me substitute the value. Now pressure is how much? 1.01, 3 into 10 to the power 5. Your volume is 22.4 into 10 to the minus 3 divided by, for 1 mole of gas means N equals to 1, into your temperature is 273. Okay, so if you simplify, we can write this as 1.013 into 22.4 into, now 10 to the power 5 and 10 to the power minus 3. The 5 minus 3, if I subtract, it will be 10 to the power 2. So 5 minus 3 means 2. Okay, divided by 273. So 5 minus 3 is what? 2. Which means I write down now this as 1.013 into 22.4 into 10 to the power 2 means what? 100 divided by 273. Okay. Now in this case, we can simply do the simplification by multiplying these quantities in the numerator and divided by the denominator. Okay. Now 1.013, if I multiply with how much? 100, it will be 101.3, because there are 2 zeros, so this 1.013 into 100 means nothing but 101.3 into 22.4 whole divided by 273. And children, just multiply these two value, 101.3 into 22.4 divided by 273. If you do, you get approximately the value, and this value is how much? 8.31. So I'm writing directly the value, that is 8.31. You can check it out, the value of what? This R, which is 8.31. So this is the universal value of the universal numerical value of universal gas constant. But this constant has a unit. So let me write the unit. So finally, the value is 8.31 joule per mole per Kelvin. Yes, so because we have already learned the SI unit of what? R, and the unit is joule per mole per Kelvin. So children, look at this part. What is the numerical value of universal gas constant, which is 8.31 joule per mole per Kelvin. So this value is important, and we use this value even for the numerical problem also. So we calculated, we express the SI unit of what? R, at the same time we write the numerical value of what? R. Now children, now we even write the dimension of R. Yes, sometimes you will be asked to write the dimension of this universal gas constant. Okay, so for dimension of R, let me just start with the SI unit of R. Since SI unit of R is what? SI unit of what? R is nothing but joule per what? Per mole per Kelvin. Joule per mole per what? Kelvin. Or I can simply write this as joule by mole into what? Kelvin. So let me just write in word, joule by mole per Kelvin. Now joule, as you know, is the SI unit of work, and you have learned what is the dimension of work. So for that, let me just write directly the dimension of work. I mean the dimension of R is nothing but, I write down the dimension of joule means what? Work by, now mole is simply a number, so it has no dimension, so it is dimensionless. So this is simply a dimensionless divided by the dimension of what? Kelvin. Now Kelvin is the SI unit of temperature, that means the dimension of temperature. So temperature also has a what? Dimension. But children, let me just write at the bracket that mole is dimensionless. So mole is dimensionless. So is a dimensionless quantity. Okay, so mole is dimensionless quantity which is neglected. We can simply neglect this quantity when we write the dimension. So dimension of R is nothing but dimension of work by dimension of what? Temperature. Okay, the dimension of work, as you have learned, is nothing but ml square T minus 2. See, dimension of work or dimension of energy is same. The dimension of work is what? ml square T minus 2. The temperature also has a dimension, and the temperature dimension is given by what? Theta. We can write theta is the dimension of temperature. Okay, dimension of temperature can be written by theta, or sometimes it can be written as what? K also. So let me use theta only. Okay, so if I take this quantity in the numerator, so let me just write it down. It will be ml square T minus 2 into theta to the power minus 1. If I take in the numerator, theta to the power minus 1. Now if I combine, it will be ml square T minus 2 theta minus what? 1. So finally, the dimension of R is ml square T minus 2 theta minus 1. So sometimes you will be asked to write the dimension of what? A dimension of universal gas constant. But remember this part, when you write the dimension, mole is simply a number which is a dimensionless quantity which can be always neglected. Okay, whereas we write the dimension of R in terms of dimension of work, that is joule, expressed by joule unit, and dimension of temperature which is expressed by the unit Kelvin. So this is the detailed explanation of R, the universal gas constant. Now in the next YouTube video, we express another constant, important constant, that is called Boltzmann constant.